What is the wavelength of the photon associated with an electron transition from 6 to 1? Well, this thing is going to be emitted, right? Because it's a downward transition, right? 1 is the lowest energy level. 6 is how much higher than that, right? And so we're making a downward transition. Closer to the nucleus is a lower energy, right? And the orbital 1 is the one closest to the nucleus. So this is definitely an emitted one. We've got the nucleus, and we're going from way out here to way in there. And you imagine 4 orbitals in between, right? All right, so it's definitely an emitted photon. Let's figure out the energy of 6 is minus 13.6 eV over 6 squared, which is a small number. That's negative 0.377, a lot of sevens, EVs, right? And then the energy of the first one is negative 13.6 over 1 squared is negative 13.6. And so the energy difference is just 13.6 minus 0.37, right? So the energy difference is, so you just subtract those, right? And you get 13.22, a lot of 2's, EV, right? Okay, so let's see. What is the wave? Oh, we got to figure out the wavelength. Okay, so multiply by 1.602 to the minus 19th. All right, and that is 2.118 times 10 to the minus 18th, and then the wavelength is hc over E, 6.626. Feel free to use this shortcut. There's actually a shortcut one where you can go directly from EV to nanometers, but you know, I've got my pride. 2.1182. All right, so 6.626 E minus 34 times 3 E8 divided by the answer I just got. And I get 9.38 times 10 to the minus 8th, which would be the same as 93.8 times 10 to the minus 9th meters, which would be the same as 93.8 nanometers, right? Okay, now the fact that it's emitted is because it's a downward transition. We're going to a lower orbital. And then 93.8 nanometers is definitely ultraviolet, right? We can see the bluest blue is like, 350 nanometers or 400, and this is much shorter than that. So anyway.